Alrighty then. So, the math dealer here, and we're going to break down some logarithms. Maybe we'll even cut into some logs. Alright, here we go. So the key thing about logarithms is just understanding what the heck they are. Okay, so the logarithm is a function. So sometimes you'll see like the log of 8 base 2. And you say to yourself, okay, so what is this actually equal to? Well, the way I've always thought about it is I'm sitting there thinking to myself, 2 to what power is going to give you the 8? So we all know that 2 cubed, of course, is 8. And so the answer to this is 3. And so if I had like the log of log of 25 base 5, you think to yourself, 5 to what power gives you 25? So of course we all know that 5 squared is 25. And then some people go, okay, well I get that. Well, what about something like this? What if I have the log of 0.25, also known as 25 hundredths? Us math people, we don't really like to say point, but we understand that that is the common language that's out there. Anyway, so if I say to myself, okay, 4 to what power gives me 25 hundredths, also known as 0.25? Well, if you think about that, 0.25 is 1/4. So 4 to what power gives me 1/4? Well, of course, we all know that -1 is the answer to that question, right? Because when you take 4 to a negative power, the blinker is on, right? We've talked about that in class before. That blinker is on. So that blinker says, dude, you need to change lanes. So we change the lanes and turn the blinker off. Right? Okay, so that answer, of course, is -1/4. That would be the answer to that logarithm. Now, the common log is when the base is 10. So if I said the log of 100 and didn't write the base, you can assume that the base is 10 there. So the answer to this is 2. Because, wait for it, 10 to the second power is 100. So I always tell my students that the answer to a logarithm is the power of the base. All right, so if you can kind of get that into your head, that a logarithm is equal to the power of the base, that might help. So oftentimes I tell my students, right, not just me, it's kind of a math thing we do here. So if I have the log of y base b, that is actually equivalent to b to the x is equal to y. So you always think to yourself, okay, well, if I'm solving for x, I have to think b to what power gives me that number. So and this works for all of them here, right? So if I have the log of, let's say log of 27 base 9, I'm thinking to myself, hey, 9 to what power gives me 27? Well, now this one you might have to think a little bit more about, because 9 and 27 don't have common bases yet. Right? And I say yet because we all know that 9, of course, is 3 squared. And you do know that 27, oh, by the way, is 3 cubed. Powers to powers, you multiply. So that gives me 3 to the 2x is equal to 3 cubed. And lo and behold, wait for it, 2x equals 3. And x is equal to 3 over 2. So the answer to that question would be 3/2. So that's basically just kind of the breakdown of what a logarithm is. All right? So you're always thinking to yourself, the base raised to the power gives me that number. And that number, by the way, is known as the argument. But I really think if we start calling it the logand, it's going to stick. What do you think about that? Right? My theory behind that, just to throw it out there, the term inside the radical symbol is known as the radicand. The term inside the division symbol is known as the dividend. So why shouldn't we call the number next to the log the logand? I know, right? This is the math dealer signing off. Stay tuned for the next one when I break down the properties of logarithms. Man, we are just cutting down some logs, aren't we?